also in our files. So I got it started. Well, I am really, really excited today to bring to you two phenomenal guest speakers. So our first guest speaker is a former middle school student of mine who has gone on to become a space scientist in her own right. She works here at Goddard Space Flight Center. And every now and then she and I make time to get together and have lunch, but it doesn't happen as often as we would like. And it's just always the most, the biggest pleasure and so exciting to see one's students as they grow up and grow on and start adulting, and certainly Mary is just one of my absolute favorite former students. So she's going to tell us about her career, how she got into her career, and what she does as a solar scientist, why we should care about space weather. Because, of course, that's one of the big things that people are studying as we are looking at the corona and as we're observing the eclipses. And then I have Heather Mortimer, and even though you haven't met her yet, Heather has made many of the resources that you have seen and used when we were doing the working with the annular eclipse, and she is in the process of making and has made several resources, including one that the whole reason she came up with this idea was because you all asked for it, and that was a trifold brochure or a brochure or a one-pager that you could use when you're explaining to people how to use the Globe Observer app. And Heather is also an early career woman. She's also right here in my building when she's when she doesn't telework, and she lives close by. So it's a great pleasure to be able to have both of these guest speakers for us today. Excuse me. And so we will get started first with Mary Arone. And Mary, anytime you want to share, feel free. And if you need anything, let me know. We're very informal here. We're all very chill.
Okay, I will go ahead and share my screen.
And I'll let you know when I can see your slides just fine.
Great. So I'm going to share, let me see. I'm going to pull up the PowerPoint and put it in presentation mode. Do you see the first slide?
Let's see, I don't see it yet. But it could be that I'm delayed on my end.
I know they were having a little bit of a delay in the internet here on center. I think it's been resolved. I can't see the way I'm sharing. I can't see.
Oh, I get that. I still see myself and my screen.
Okay, give me 1 second. I'll share again.
I know it's always so weird when you can't even see the screen. It disappears as you're trying to share it.
Okay. I think this is the correct.
Yep. This is great. And we're not right now. We're in there you go. You got it.
All right. Is it presentation mode, or do you see my
no, you're perfect. Now it's
okay.
Although, you know what it's doing? Sorry, I'm going to bug you one more time. It's showing us your next slide too. I wasn't sure if that was just.
Yeah, it's showing the notes. Okay.
You'll get it. Almost there.
I actually don't usually use Zoom, so this is okay. I'm going to share the window.
Now it is perfect. And wow, what an image. All right, I'm going to mute myself, my dear, and take it away.
All right. I can't see the Zoom, so if there's any questions or anything in the chat, please feel free to stop me. But I'll go ahead and get started now.
You do that, and I'll ask you questions at the end so we don't interrupt you.
Okay, great. So my name is Mary Arone, and I'm going to be talking about space weather and space weather impacts and why it's important for us here on Earth and in space and in the context of like NASA. So I'm a space weather analyst in the Moon to Mars Space Weather Analysis Office, which is located in the Heliophysics Division at NASA Goddard Space Flight Center in Greenbelt, Maryland. And so I'm an employee at the cooperative agreement with CUA, and I work here on center. So I'm really happy to be here today. Thank you so much for having me. So I wanted to start with a little bit about me and my path into space weather. So I've been a space weather enthusiast since 2008. So like in middle school, I would go on the computer with my parents' permission and I would log on and look at the sunspots. And I didn't really understand a lot about what I was looking at the time, but I thought it was really fascinating to, look at a star up close like that. And that interest was just, encouraged so much through my education and being in Dorian's Miss Janie's astronomy class and astronomy camp, and just having really supportive teachers and mentors and my parents as I went through school. In 2012, I had my first high school summer internship here at NASA Goddard, where I worked with a group doing some like space weather research and space weather focused things, which just in 6 weeks, I learned a lot about space weather, and I was really passionate about it. And then in college, I returned to them as a NASA intern for a few years, and got to do that in conjunction with my studies, which was really rewarding. In August 2017, I observed the total solar eclipse. I traveled down to Columbia, South Carolina, and totality was about 2 minutes, 30 seconds there. And it was easily one of the best experiences of my life. So I'm really looking forward to going down to Dallas, Texas for the total eclipse this year. In 2018, I graduated with my Bachelor's of Science from the University of Maryland, Baltimore County. And in 2019, I found my way back to NASA Goddard as a support scientist, doing some more Earth science focused, supporting some research in the context of Earth science and remote sensing here. And then in 2021, I found the opportunity to go back into space weather and became a space weather analyst with the M2M office, as we call it here. And so I've been here a few years now and just have had so many amazing opportunities. This picture on the top here is me presenting at a workshop for space weather that took place in Ushuaia, Tierra del Fuego, Argentina this past year. So we led a 2-day tutorial for students and researchers from throughout Latin America on space weather. We've also supported, our team did 24/7 space weather coverage for the Artemis 1 flight test, and we'll be doing that for Artemis 2 as well. And so we're really excited about that. And so it's just a great opportunity to support space weather for NASA missions. So I wanted to start out with a definition of space weather. So this is one such definition. Space weather refers to variations in the space environment between the sun and Earth and throughout the solar system that can affect technologies in space and on Earth. Space weather is primarily driven by solar storm phenomena that can include coronal mass ejections, solar flares, solar particle events, and solar wind. And the image I have on the left here is a space weather event, and it is heart-shaped. This is back from Saturday. This event actually happened, and so I thought it was a great event to show because it's the day after Valentine's Day, and it's really pretty. So what does a space weather analyst do? What do I do? The easiest way I can think of breaking this up is that I observe, analyze, and model events for NASA missions throughout the solar system. So we start by observing the sun and any space weather environment that could be impacted. So this includes looking at images of the sun. So most of these images are from SDO, the Solar Dynamics Observatory. And we look at the sun in different wavelengths to see different layers of the corona, the sun's atmosphere, to look for different features on the sun and the eruptions we're trained to look for that could be, produce a space weather event. And so when you see one of these eruptions on the solar disk, you may observe them in the coronagraphs. So these three images on the bottom left here are coronagraphs. So basically it's creating an artificial eclipse. So the white circles here are the sun, and by blocking out the sun, you can see the outer corona and the dimmer material, streaming off of it. And those are coronal mass ejections, so masses of plasma and magnetic field that are ejected off the sun. We also monitor like different graphs and plots that measure different high energy particles in the solar wind that can create like a radiation hazard for missions. We also look at different parameters of the solar wind. So the solar wind is the stream of particles that's constantly like emanating from the sun and streaming out through the solar system. So we measure different parameters of the solar wind to see if there are any enhancements that could be an indication of an event we have to keep an eye out for. Next, and this is really where the value of an analyst and the human in the loop comes in real time, is we are looking for all these events and we're documenting them and linking different events that could be associated together and issuing notifications for NASA missions depending on their criteria of they're interested in. We spent a lot of our time measuring these coronal mass ejections that are in the coronagraphs. So using CME analysis tools and basically using the geometry, we're able to obtain the direction the CME is going, the speed, and the width of the CME, how wide it is. And then that brings me to modeling on the right. So the top right pane here is we're able to plug these parameters into a model that will show us what direction the CME is going and what it may impact. So we don't just look at things that are Earth directed, but anywhere in the solar system that NASA has a mission. So this here you can see the rainbow pinwheel. It's really pretty. You can see the sun is this white circle in the middle and Earth is this yellow circle here. And then this like wave bubble you're seeing here is a CME propagating through the model. This is just one frame of it. We kind of play them on a movie loop too. But you can see that the CME is directed towards Mars in this case. The model will also, show us this plot of when it thinks the CME would arrive, and you would see a shock, observe a shock that would look this enhancement in the solar wind parameters. So those are some of the events where we model for, and we're keeping the NASA mission operators in the loop throughout the events, and we're looking throughout the solar system for these. So looking a little closer to Earth, one of the strongest space weather events on record, and a really famous one, is the Carrington event that occurred in late August and early September in 1859. So Richard Carrington and another astronomer, Richard Hodgson, were looking through their solar telescopes and documenting the sunspots, so drawing the sunspots they were seeing. And this is one such drawing of them. Without going into too much detail, this is like a massive sunspot, very complex. And during this time, while they were actually looking into the telescope, they observed a solar flare, this bright flash of light. And then less than a day later, about 18 hours later, aurora were observed as far south as Cuba. There were reports of people like going to work, getting up and going to work because they thought it was daytime outside. That's how bright the aurora was throughout the United States and in other parts of the world. There were so one of the main technologies to communicate at the time were these miles and miles of telegraph lines. And there were, so some of these telegraphs caught on fire. That's how electrified like the atmosphere was in the electric like current. And some telegraph operators were injured from these and just the power like enhancements. And this is one conversation that was recounted in a newspaper between two telegraph operators who were actually able to turn off their machines and were still able to communicate just from the energy from the event. And so there's a lot of research going into what a storm of this size could do today with all the technology, modern technology we have, and how dependent we are on it. There could be significant impacts to our everyday life if an event of this size were to occur. They think we've seen some close calls, some Carrington-like Carrington-like events that have not been direct hits to Earth since then. But so this was a good, lesson from the past about what space weather impacts could be. One really visible, I think, well-known impact of space weather is aurora. So these are one of the most iconic and beautiful manifestations of space weather. I think the International Space Station has to have one of the best views of this, like in this picture here. So these are caused by geomagnetic storms due to the interaction of the solar wind and the Earth's magnetic field. So these charged particles are interacting with the gases in the atmosphere, primarily oxygen and nitrogen, to produce these colorful displays. And so I have a movie here, and I'm going to play it, and I might also try to pause it at a couple different parts. Let me see. Okay, I think it's moving. So this is going to show a coronal mass ejection as it moves through space and interacts with Earth's magnetic field. So you can see the sun, and it has these massive sunspots on it. And then there was a bright flash for the solar flare. And the coronal mass ejection, that this massive plasma and material that was impacted was traveling throughout the solar wind. And here it is hitting Earth. So I'm going to back this up a little bit. Okay, I will keep talking as it replays. Sorry. So it hits the Earth's magnetic field. So the Earth has a magnetic field that's basically like a dipole magnet, but it takes on its shape due to the interactions with the solar wind. So the day side of the magnetic field is compressed. So you can see here, and that is it's constantly being buffered by the solar wind. And then the night side of the magnetosphere tapers off into what is known as the magnetotail. And then in the magnetosphere, due to all these complex processes, magnetic reconnection can occur. So basically, huge amounts of energy are released when these magnetic field lines are changing their configurations, and particles are accelerating through the Earth's magnetic field, and that's producing the aurora here. Okay. So in terms of space weather impacts, there can be space weather impacts for different technologies on Earth and in space, and the impacts on Earth can extend all the way underground even, and they have the potential to disrupt everyday life. The Earth's magnetosphere protects us from space weather, but it's not impenetrable. So solar flares are one of the types of space weather that can produce some notable impacts. So these are bursts of electromagnetic energy from the sun that are lasting minutes to hours. In terms of their intensity, they can produce strong X-rays on that end of the electromagnetic spectrum, and these flares can degrade or block high-frequency radio waves in the Earth's atmosphere. They also produce solar energetic particles that can pose a radiation hazard to astronauts in space. Coronal mass ejections. I want to mention this is a flare that actually happened back on last Friday that we can see here. So we use this wavelength that's colorized in teal here, and to look at the flares that feature on the sun. And usually this would be a really crisp, clear image of the sun, and you can see it's kind of like blurry and saturated from the strength of this flare at the time in the camera. So flares can be one of the drivers of coronal mass ejections. You don't need a flare to have a CME, but due to that release of energy, it can trigger some of that plasma and magnetic field to propagate in the outer corona. So these can travel anywhere from less than 250 kilometers per second to over 3,000 kilometers per second. So this is what we're using the coronagraph for. And this CME actually here, it's going off to the right, was actually associated with that flare. These can be detected in situ data at spacecraft between the sun and Earth when they pass over the spacecraft. So that can give us some lead time to for space weather events that might be Earth directed. And these can also cause the geomagnetic storms that lead to aurora. So going into those storms, they can create disturbances in the ionosphere, which is a dynamic layer of the Earth's upper atmosphere. It extends from 30 to 600 miles above sea level, and it's basically full of charged particles. And changes in density and composition driven by space weather and the solar wind, but actually intense Earth weather events, terrestrial weather, can impact the ionosphere as well. And these can impact the radio and GPS signals that are relying on the ionosphere to travel through it to reach their target or to bounce off the ionosphere. So it can disrupt the signals, lead to changes in like the accuracy of the GPS, or loss or issues getting the radio signal. So impacts to Earth, close to home here, the currents induced from the geomagnetic storm can impact power systems. So the current can travel underground through like pipelines and the rocks to once it reaches like a power grid or transformer, it can result in electric grid disruptions. There are also the disturbances in the ionosphere that can impact GPS and cause radio blackouts, like I mentioned. And then there are also impacts to airlines and airline pilots if they're flying high altitude polar routes, more towards the poles at those higher latitudes. They can be exposed to an increased radiation dose over the course of their career. And the ionosphere can also, cause issues with communications for them, especially using GPS and such. Next, for impacts in space. So one of the hazards, space weather can cause radiation exposure for astronauts, and with this increased radiation exposure, they may have to shelter in a more shielded area of the International Space Station until the storm subsides. So in the context of, the Artemis program, which is going to the moon to establish a sustainable presence on the moon, and then, prepare to go beyond to Mars, the moon spends some time outside of the Earth's magnetic field, and also just has a different radiation environment. So it's important to understand the lunar environment and the impacts it could have on radiation exposure. This is also important for even space travel, even deeper in space, where you would be completely outside of the Earth's magnetic field. In terms of spacecraft, there can be different damages to the electronics on it, like surface charging. The star trackers can be blinded, so basically that's what it uses for navigation and to orient itself. So that can cause issues. The solar cells it's using to get power can be damaged. And another important one is increased satellite drag due to the thermal expansion of the atmosphere. So during a space weather event, when more energy is pumped in from the solar wind, it can lead to more thermal expansion, and then the satellites in low Earth orbit can have some decay in their orbits, and that can shorten the lifetime of a spacecraft. And for my last slide, I would just like to say thank you so much. This is one of my favorite images of the sun. It's a smiling sun, so it was great to log on to work every day. I think this was in October 2022, and to see the sun smiling at you. So these are basically just some dimmer regions on the sun that appear dimmer in this wavelength to our eyes, because the magnetic field lines on the sun are open, so to speak. So basically they're connected somewhere else in the heliosphere or on the sun, and allowing the solar wind to stream out more freely. Um, so that is another driver of space weather events. But in the meantime, they can look really dramatic on the sun, and also really cute sometimes. So thank you very much. I'd be happy to answer any questions.
Wow, Mary, what an amazing presentation. And there are a couple of questions, so I will ask you them, and then we'll see if any more come up. But just what a fascinating presentation. Well done. You get an A plus, an A
Thank
plus
you.
plus. So first question that I have is, let me come back to my questions here. Do all stars emit CMEs? And if not, what is special about our sun that it does?
Yes, so that's a great question. Um, one thing that makes our sun, one thing that drives the CMEs and all this activity on the sun is one of the theories is a solar dynamo. So just the rotation and convection in the sun is producing these changes in the magnetic field. So I don't entirely have know that much about um, stellar cases. So that's what they call it in astrophysics, I guess, when they're talking about space weather, but on different stars. And it's really cool that there's a whole other branch of heliophysics basically studying that. But I know there's different, types of stars and different stages of um, star development. And so what is going on in a brown dwarf, for example, as its core is basically dying versus what's happening in a very dynamic, energetic core could be different. And I know there's stars that are emitting CMEs bigger than ours, for sure.
Wow, and like you say, what a great question. Just because something happens in our neighborhood doesn't necessarily mean it's happening in other neighborhoods. And it's kind of neat to have the technology to begin to answer some of those questions. So another question is, what will be the scenario when Earth has a magnetic field reversal? Great question.
Yes. Um, so on the sun, that happens about every 11 years as part of the solar cycle. And so that's why you can get periods of very increased solar activity and then some called solar maximum, and then quieter periods called solar minimum, depending on the configuration of the magnetic field. For this, Earth has on the time scale millions of years for the magnetic reversal. I know there's a lot of research, some of it with a lot of different points of view of what could happen during a magnetic reversal. Um, so I don't have an answer for that one entirely. I think having a human record of it, present day, if that were to happen, would be really fascinating and informative, because there are a lot of different theories about if there would be an impact, or what we would see.
I remember learning that and when we look back at the biological record, because there is a biological record, even though we weren't around, we didn't see any mass die-offs. So we don't think that it will have, that will impact us. Of course, who knows? We're a different species, but since we didn't see any mass die-offs, and I don't exactly know when the last field reversal was on Earth to know what kinds of biological species were around. But it truly is just a fascinating field of study. When I was teaching middle school, I had the good fortune to be working with some folks at NASA, and we did entire classes just on space weather because once we learned about it, we were like, this is too fascinating. So we would have different stations where the kids would go, and for our whole semester, we would study the sun and the aurora and all of these sorts of things because it is just fascinating. So Mary, I had a question. In 1859, during that Carrington event, you were talking about the two folks looking at the sun through the telescope. Did they have proper, eye protection back then, or did that end up like it did with Galileo, resulting in blindness?
Yes, that's a great point. They were using protection with their telescope observing it, and so you should never use a telescope to look directly at the sun. unless you have the proper filters. And yeah,
Now
so
that's good to know that even 100 years ago or and plus, that they had that understanding of the impact on the eyes. And then I had another question. Then I'll ask another question from the chat. Do we know that this is a very active solar year right now? I believe we're at max or will be at max next year. Do we anticipate there'll be any impact on the solar eclipse because of this solar maximum?
yes. So I think the corona could look different during the total eclipse. So if you have all of the CMEs, the coronal mass ejections in the corona, I'm hoping that we'll be able to see one in the corona during this, and it would just look more. I think I saw it described as like a spiky porcupine, just more like material coming off of it. So I do think it could make a difference. I know there's a lot of like modeling going on and people trying to predict, scientists trying to predict what the corona will look like during the total eclipse, because that can inform a lot about the processes going on like closer into the sun and what our modeling capabilities are with that.
Very, very cool. Gonna be at an absolutely fascinating event. So then there's another question, a little more personal. When you are in Dallas for the eclipse, will you be part of any of the official eclipse events, or will you be an independent enthusiast?
Yes. Right. As of right now, I'm going independently. I would not miss this, no matter what. So I'm staying at my aunt's house. Fortunately, visiting family in that context. I know there are some events going on that NASA is involved in, but at the moment, I'm not officially part of any of them.
Well, and I wanted to throw in that if any of our master naturalists will be in Dallas and would like to be a part of the official NASA event, I have been asked by one of the people who's running the evaluation portion, and they are looking for some master naturalists from Texas to join. So just email me, and I'm also going to be sending this around. But I kind of figure, since Lynn brought that up, I figured I'd throw that out to you all. Let's see, I'm seeing a lot of advertisements. And I guess let me start off by saying to you, and you can do this where you go to reactions. Give me a thumbs up if you've ever seen the aurora. Let's see how many of you have ever got to witness an aurora. So I'm on there, Mary's on there. Okay, we've got Heidi. Um, Cool. Man, I'll tell you, that's another way, way, way cool thing. And Len too, cool. So here Lori is saying, I've seen lots of advertisements for trips to Finland, Iceland, etc. for 2025, saying that time will have the biggest auroras. Is that true or is that hype?
So the latest predictions for the solar cycle is that solar maximum will occur in late 2024 or in 2025. So in general, that's when you see increased solar activity, and there's the potential for more coronal mass ejections that could be Earth directed and cause geomagnetic storms.
So you can't say with 100% certainty, but you can say you're as certainties go, it is higher than it would be generally. Really, really neat. You've inspired me, Mary. I'm going to add to our story map a whole section on space weather because it really is cool. And even though that's not necessarily what we're studying specifically as we're looking at the eclipse, I think it's really cool. And I also would be fascinated to know if there's been any research on the impact. Most of the people that are on today, Mary, are master naturalists. So they study lots of aspects of particularly animal and plant life. Be really neat to know if coronal mass ejections and solar flares, um, how much and how they impact life, life in animals on Earth. That's and one more thing to say about that. With the satellite mission that I work for, we were bummed to find out that because of the intense solar flares that have occurred over the last year, it brought our our orbit height down from where we wanted to be about 370, where we had been, down to about 350 miles above Earth. So we had to use some of our very valuable fuel because we have to save enough fuel for a controlled reentry at the end of our mission when we start kind of degrading and don't have enough energy left. But we had to use some of that valuable energy supply to boost our orbit to get it. And we went up to 400, knowing that while we were going ahead and using that fuel and taking advantage of it, we'd go ahead and go up to 400 miles above Earth, so that way we won't degrade too much as we enter and stay in this really active solar cycle. So, wow, Mary, so cool. And marvelous. Well, I thank you so much. And if any other questions come up, if you have time to stay on, just go ahead and answer them in the chat. And if not, if you don't have time, I can't thank you enough. I'm gonna bug you again sometime and see if we might get you for another from one of my lifelong learner classes.
Okay, great. Thank you so much for having me. I'll stay on. But yeah, thank
Awesome.
you.
You are so welcome. Well, now I am going to bring her slides up. So let me do my little act here for Heather. Whoops, go back here. Heather slides, pop them up, and come over to share screen. And
Oh,
we'll,
I can also share screen, Dorian.
oh, cool. Sounds good. I think it's just easier that we don't have to keep telling me, please click, please click. Let me
Yes.
try to stop sharing now that I started, though. Wow. Okay, now you should be able to, I think.
Great. And I will be jumping between a few different programs while I'm presenting. So just to let everyone know that I probably will not have access to the chat um, until the end of the presentation, but I'll be sure to go back through the chat at that point. So you'll also have to excuse my messy computer. I'm going to go ahead and share my entire screen because at the end I'm going to show you all a little bit of behind the scenes stuff for fun.
Sounds like a plan.
All right.
I'm sure many of us confess to messy computers.
Can everyone see that all right?
You're good. I'll stop my talking.
Great. So today I'm just going to give you an update on some of the printables that we have available and that will be available soon for the Eclipse. So my name is Heather Mortimer, and I am the senior graphic designer on the Globe Observer team. Um, I do have my CIG, which is Certified Interpretive Guide, and CPAC, which is Certified Professional in Accessibility Core Competencies. Um, but my background is actually in informal education. And so in high school, I actually uh, started volunteering with the National Aquarium and stuck with that for a really long time. Eventually went on to do work with zoos and aquariums, parks, museums, and a little bit of classroom instruction. And then I was very fortunate to also graduate from UMBC in 2018. And I did a program where you can actually make up your own degree program. And so the one that I came up with was called Science Communication. And it essentially combines some courses from the arts, journalism, as well as education and what I called topical courses. So they were usually topics classes in the sciences. Um, and so the Global Reserver team brought me on primarily to do outreach to informal educators. And so I manage our toolkit for informal educators as well as create the materials that go in there, which I'll be sharing some of which today. And this is a picture of me at the Albuquerque Balloon Fiesta during the annular eclipse. So while I'm based out of Greenbelt, Maryland, lately I've been spending a lot of time in your part of the world. I've been in Lubbock, Texas, quite a bit, and so we drove over to Albuquerque to help out with the NASA event there during the annular eclipse. And so this is a photo from that experience. So Dorian will be sharing the slides with you, and hopefully you find this to be a really useful resource. But all of these links are also on our website. This is essentially the master list of all of the printable Eclipse materials that we have available now or are planned to be created prior to the eclipse. And we'll be going through these one by one. But we have the pinhole projector, which some of you may have seen. We have a few one-pagers, including the science one-pager, the how to use the app one-pager that Dorian showed you all earlier, and an overview one-pager, which is still in development. We have some worksheets, including an Eclipse journal and an air temperature data sheet, and some displays. So they're tabletop signs that you can print and use for Eclipse programming. So anything here that is linked is currently available on our website. Anything that you see marked as coming soon is, we have everything that we need. We just need to add some of the final touches, and those should be available in about 1 to 2 weeks. You'll see there's a lot of Spanish versions where we just got the translation back, and so as soon as the translation is put into the actual document, we'll get those up on the website. And then anything in development, we still have a bit of work to do. I'll give you a preview at the end of this presentation, and those should be available in a few weeks. Obviously, we want to give you all time to get ready and know what's available to you. So hopefully those will be available very soon. And then to find all of these resources, you can go to our website. I have the link here, but if from our homepage, you can also open the menu for Lead a Program and then select the Eclipse page. And so that is the Eclipse Toolkit for Informal Educators page. Once you scroll all the way down to the bottom of this page, and I can actually show you that, that's where you can find all of our resources. And then underneath each resource are the various versions that we have available. So I will go ahead and share some of those with you. This is our pinhole projector. So unfortunately, we don't have many printed versions of this left. They were very popular during the annular eclipse. But it is available on our website. Could potentially be a really good arts and crafts activity, since you will want to cut out the actual projector and then punch a hole in the center to turn it into a pinhole projector. And this one is bilingual, which is really nice. So you don't have to have multiple versions of it. You have English and Spanish on the same one. Just note when you download it from the website, the first page that I have here is flipped upside down, since that is how it prints best. So like I said, unfortunately, we don't have too many of the die cut versions left. But you can still download this from our website and cut it out yourself if you would like. Another resource that you might already be familiar with is the science one-pager. So this one on the front gives a pretty general overview of some of the effects on Earth's atmosphere from the eclipse. So obviously air temperature is affected, which then also has an impact on clouds and wind. And then on the back, you get a little bit more of an in-depth explanation of those different processes. As you can see, this is a very colorful, ink-heavy graphic. So we did also create a low ink version. And then this is the trifold brochure that really walks you through how to use the Eclipse tool. So this is really useful on the actual day of the eclipse. And it's also available in 2 versions right now. This is the flat one-pager version. It's front and back. And then there's also a trifold version. So you'll notice this one's a little bit out of order. That is so that once you fold it, the numbers are in the correct order. And so this one we recommend printing in, front and back. And then once it's printed, folding it accordion style. And basically creates a little book. And once I'm done sharing my screen, I'll show you a printed copy. In terms of our worksheets, we have the Solar Eclipse Journal. So this is really great, especially for younger audiences who may not be doing data collection, where basically they can just write their experience, what they're noticing using all of their senses. So on the front, we have what I've been referring to as an eclipse planner, where you enter the percent coverage, circle what type of eclipse it is, and then add the start, max, and end times. And what we recommend using to find that information is this really helpful tool from Eclipse Soundscapes, which is another Eclipse citizen science project. But they have this tool where you can enter your zip code or a location, and it gives you all of that information. And so then you can just plug it right into some of these worksheets, which is really helpful. Then people can sketch what the sun looks like at different parts of the eclipse. And then on the back is where all of the writing prompts are. And this is also fillable on the computer. So with all of our worksheets, we do try to make sure that people can fill them out on the computer for accessibility reasons. It's also really useful, if you're handing these out to a classroom, you can go ahead and fill the Eclipse planner in yourself before you print it, if you have a pretty good idea of where everyone is going to be observing from. So this is available now, and the Spanish version is coming soon. Next is the air temperature data sheet. So this is pretty much finished. We're finishing up the final touches. Again, it has an Eclipse planner. And then it has all of the information that we need in order to enter your observations into the Globe database. So if you have anyone who doesn't want to use a cell phone for any reason, doesn't have a cell phone, doesn't have the app, this is a great alternative. You would describe your site, let us know some information about your thermometer, add your air temperature measurements, and then at the end, if you'd like, you can graph your data. This is, of course, something that the app does automatically, which is really helpful. But you can also do it the low-tech way. And then once you're done, you can take photos of each side of this worksheet and send them to the email on this page, and we'll get that entered into the database for you. And then finally, we have some just display materials. So this is a tabletop sign, just generally about the Eclipse tool. It has a still from our video. If you haven't seen that yet, it's pretty fun. And then for after the eclipse, so if you're doing an event that kind of spans the length of the eclipse and then maybe goes after, which was the case in Albuquerque, we actually have a sign that you can replace the eclipse sign with, letting people know that they can continue to take observations using the clouds tools. While the eclipse tool is temporary, it's just for the eclipse. The rest of the Globe Observer app is always available for people to take observations with. And the clouds tool is one of the tools within the app. And so now for our preview, I will go into InDesign. So this is a very anticipated product. This is our kind of, overview one pager. And the general idea with this is that everything that you need to know before the eclipse is on the front, and then the kind of nitty gritty of what you'll actually be doing during the eclipse is on the back. And I know it looks pretty complete here, but we actually created some new illustrations to go in the app, sort of highlighting the most important things we want people to know. And I really liked how those illustrations turned out. So we're trying to incorporate those into this overview one pager. So we have, uh, an image for how to choose a thermometer. Of course, you can use a digital or a liquid filled thermometer. You can't use a weather app as a substitute for your thermometer. We also really want to emphasize that people should take observations through all phases of the eclipse, which is about 2 hours before and 2 hours after max. And that their thermometer should be placed in the shade. So when the sun hits your thermometer, it can actually kind of mess up your measurements. So we really want to encourage people to make sure that they're placing their thermometer out of direct sunlight. So once all of these new illustrations are incorporated, hopefully this will also be up on our website for you all to use. And then finally, here is my contact information. Um, so, I would really love to hear what's most useful to you. Like Dorian said, the idea to do the trifold really came from this group. So taking requests, no guarantee that we'll have time to create everything we want to create. But it is always really helpful to hear what's most useful to you all. So I will go ahead and stop sharing my screen and show off how you should fold the trifold. So it works just fine if you fold it brochure style. But I really like folding it accordion so that you open up to steps 1 and 2, flip it over, you get step or 2 and 3, flip it over, you get step 4, and then open it back up again and you get 5 and 6. So yeah, I hope I know that was a lot of material to throw at you, but like I said, it's all on our website, or it will be very, very soon.
Wow, Heather, thank you so much. And Heather and Mary, both of you. Sometimes one gets a bit discouraged with the things that are happening in the world, and we just wonder, are we going to be okay? And listen to these two early career folks chatting with us and sharing their expertise and being so wise, but also able to communicate with others. And I don't know about you. I'm sure I'm preaching to the choir there. It gives me such hope. So thank you, thank you, thank you. That's just truly appreciate it. Lots of thank yous in the chat. And then Lynn Travis threw out, and this is very important. Cell phone use may be limited depending on where you are because so many people are going to be there, kind of like at a Taylor Swift concert or Super Bowl game. And so, that's a great idea to have some of those consumables with you just in case this technology that we are so used to relying on isn't around. And Heather, I'm
That was
so
a big issue at Balloon Fiesta. People really wanted to download the app and they just couldn't, because even though they even set up portable cell towers around the Fiesta grounds, and it was still too much. It was still really hard to use your phone.
broke the internet. Now, one thing that's kind of cool though is if you already have this downloaded, and of course all of you, I imagine, do, then you can add your data. So adding data to this with any of our tools doesn't require internet connectivity. It requires internet connectivity later to share your data. But, next on, I think it's March 15th, we will have Kristen Weaver, who's kind of the guru of using this Eclipse tool. And she will talk to us all about, remind us about how to use the Eclipse tool and talk about the thermometers. And we'll get, right before we're getting out there to do this, we'll look at that. Heather, I wanted to say I loved seeing you share that Eclipse journal. I had seen it and I hadn't really thought about the use of it. And then I took the app and I looked for my zip code here in Maryland, and it looks like it'll be 88.8% coverage. And I say that because my daughter-in-law teaches third grade, and that would be a wonderful activity. It looks like it's going to be happening during the school day, and I'm wondering how they're going to manage all of that. I mean, like starting at 2:04, maximum at 3:20 when they would be kind of heading home, and then it ends at 4:32. But I wouldn't have known that if I hadn't seen that worksheet and how easy that soundscapes thing is. So I'm going to recommend
it's a fantastic tool. There's literally nothing else like it on the internet that is as easy to use to look up your everything you need to know about the eclipse at your location.
Love it. So all these are just super, super, great things for us to take away and know they're out there as we reach out to various people to to get them stoked and excited and ready to enjoy this upcoming eclipse. So last thing I'm going to share with you, just so you kind of know, you've always got this one-stop shopping, is our base camp, which all of you are on. When you come up here, over here is our message board. And so there's something, want to be involved in one of the NASA Eclipse events, and it gives some information there. When you come in here to docs and files, here is where I have gone in. So let's go to, I'm going to go to April 8th eclipses events. And I put in here some of these promotional resources. I'll also be sure I put the link in here so that I just tried to make it easier for folks. So you didn't necessarily need to go to the Globe Observer site to download it. But as Heather says, she's putting new things on there. And also sometimes I'll have downloaded it, but then there's a newer version. So the best place to look, and I will put it right up here front and center, is going to be to go to the to actually go to the Globe Observer website, because that way for sure you'll have the latest and the greatest. So we've got some various things here, and
just a quick note on that, Dorian, I would recommend pointing to the toolkit page. There's also an Eclipse resources page, and that one is primarily public-facing resources. So the things like the tabletop displays are not on that page, but everything will be on the toolkit for informal educators.
Excellent. Very, very good. So, and then I put some of those crafts and fun things that you might do. And that I'd made these folders for before and after. And then I thought, well, crafts you could do all the time. So I kind of made that separate. Sometimes you get into this sorting profile and then you realize, wait a minute, this doesn't fit all scenarios. So bear with me. You may have a different filing system thinking in your head, but crafts and fun you'd probably be doing before. You certainly could do them during and then after, while you're waiting for the traffic to die down. Some that are overall, and lots of different things that are in here. So you might go in and just kind of muck about in there. And then the story map is that online textbook. And that's where I was saying I will be sure to add space weather and put some of this information. And then we should have, trying to see if I have a webinar. Oh, presentations. So where I have this for presentations, now I'll be adding our February, where are we at now? The 15th, I'll be adding that. And then I will put in the recording of this. And then I know I can put Heather's presentation in, and depending on whether or not I can put Mary's in, I might put it in. Otherwise, you'll certainly have access to the oh, thank you so much, Lori. You'll certainly have access to the presentation and the recording, which right now I'm going to remind myself, because everything's kind of disappearing. I'm going to stop sharing. And I'll stop and just see if there's any anything, any questions anyone has, or anything that anyone wants to add for the good of the cause, but I will stop the recording.